We're ready? Okay,
Yeah.
Winston, just like I was discussing earlier about the front panel, the display capabilities, that gave us some information on what information we can get out. We haven't looked at the, what's the system, Infos? The system that,
the software
analysis?
The emphasis system.
Yeah, emphasis system,
software.
and we would go ahead and just leave that intact. There's no reason to kind of private label that or anything, but that's good analysis tool because this box will be used by the rotating equipment people to understand and do the monitoring and the performance and also the condition monitoring issues. So right now I'd just like you to go ahead and do a little description of what's inside the box, understanding that this box is, you know, the display is optional and stuff. Just to go through with this box the way it is and the different components that you see, including the power supply and the rail, and talk about the buffered output modules, and I'll let you take it over from there.
Excellent. Well, thanks, Tim. The Artemis core is the actual, brains of the system, and it is based upon our previous product, the DAC pod, which was just a monitor. We stripped a lot of the functionality out of the DAC pod, and then we added additional functionality for the Artemis, but the footprint, the geography, is all the same. So that technology is not brand new. It's been around for about 3.5 years or so that we've already got installed with customers. A basic 24-volt power supply coming in. You can do 110 into that, and then we can bypass that over if we need to. We actually have customers that are doing that as well.
Is it 24 volts? Does the Artemis core run on 24 volts?
Yes, the Artemis core runs on 24 volts.
And what do you do for the? Does this also power the probes?
The transducers, no.
Okay.
But we did try to think ahead and put enough geography within the enclosure to allow the users to put their probes in there, and we have a couple that are doing that as well.
Is that minus 24 volts you need for that? Or?
Minus 24, yes. So it's a separate power supply, but what we do is we end up piggybacking off of that. So you bring in one power supply, and it actually can power all the others, and then that goes to the sensors, and then this goes in. Now, as far as accelerometers, the accelerometers don't require an external power supply. They can be powered with the Artemis core, and that's all done internally within the module. So when we create a system, we have to kind of know the configuration. Is it, what type of inputs? Is it proximity probe inputs? Is it acceleration inputs? Is it velocity inputs? And where's that going? Because that's what's determined inside within the circuitry. A lot of the outputs, you have an individual 4 to 20 outputs per channel, as well as 4 single pole double throw relays per 10 channels. So we make this box in a 10 channel device and a 20 channel device. So it could be configured however. 20 vibration inputs, mix and match from accelerometers and proximity probes, or whatever. But they are in 2 channel increments. So if you have vibration, they're going to be 2 of that set. Customers that we have, actually has worked out very well. They are monitoring 2 fans, 8 vibration points on each, and speed on each. So they've got 8 vibration points, 2 speed points, and that fills up the 10-channel box. And they monitor completely 2 fans, and then they're using the relays, internal relays, to trip the machine due to high vibration or speed or whatever.
Right.
So we do have Modbus outputs that can be take that to a Pi system or any other DCS or any other controls type system that you have if you so choose. That's the other option is kind of you have the blank space within this area. Original design is we wanted to include the buffered outputs to come through the outside of the panel, but we ran into configuration issues with what the customers with their requirements. So we decided to make the buffers as an option.
Yeah, you have to do that because it also goes against some of the area classification.
Exactly.
You
And that's,
can't have that open.
that's what we got into the most. So we backed up and choose to make the buffered outputs an option because some people only want to use it as a monitor and they don't have a predictive guy that's going around. So there was no need to throw it in there if they didn't need it.
Right.
So the HMI is optional. The buffered outputs would be optional, as well as wireless capability to an iPad, an iPhone, or some touchscreen would be optional as well. Another last option that we have, and again, it's all internal. You can't really see this from the picture, is the real-time streaming data to the software.
To the analysis.
To the analysis, emphasis analysis software. And what we've done there with that is because the Artemis is a monitor, it can, and it has its own DSPs per channel, so it can actually interrogate the signal coming in and do some programmed analysis in the system, and that's what we talked about with the vector data on the front of the system. So we're actually able to zero in on particular bands and then even be able to use that for tripping, alarming, and time streaming data to the software. So if there is an alert or a trip or an alarm, we can actually program the Artemis core in the system to start streaming data pre and post trip so that now you have a full assessment of what happened leading up to it as well as what happened after it. So it allows you to truly capture the events and the benefit of that, because it's what we call, and we've marketed and patented as adaptive analysis. You're not having to continuously stream steady state data. You can bring in data on an interval basis, once a week, once a shift, once a month, for trending purposes for steady state. But then, due to the intelligence of the core, it can actually start streaming that data upon events that gives you that pre and post analysis capabilities.
Okay.
And that's where we find the most benefit.
All right, wrapping this up, what would you like to say for the final, your conclusion on this?
We are experiencing a huge market push for this. I mean, it's, from what we understand, especially with a small turbine-driven pump, turbine-driven compressor, the channel counts are right in the sweet spot for the balance of plant, as well as some of the critical pieces of equipment. So we're finding a real response from the market, a very approval.
And that's exactly what we said, 16 points. We talked to a lot of the turbine manufacturers and stuff, and it was actually the 7 vibration and 8 RTDs was for at least the steam turbine. So the expansion and stuff would be perfect. So it does fit along with what our market research talked about too. So, all right. Thank you very much, Winston.
Thank you for inviting us.
All right.